Okay, in the last part of this lesson series on creating a memory, we ended with the brain in this condition here. During encoding, the different sensory and perceptual areas of the brain responded to the learning event with unique patterns of activity in these different areas of the brain. And those neurons sent information up to the working memory system so we could enjoy a conscious experience of the event, but also they sent the results of their processing down into the hippocampus. And the hippocampus responded by making a memory trace, linking together the different sensory qualities of the event. So now we're going to introduce again this printing metaphor to follow the nature of these memory traces in different parts of the brain. And again, the metaphor is a printing analogy. So memories are made when the synapses between neurons are strengthened. So this is going to be representing the information learned. And for the printing analogy then, when very little ink is used, we'll just have a weak memory, so the synapses did not strengthen very much. If more ink is used, that represents the greater synapse growth between neurons and a stronger memory. And with a lot of ink, then that would represent a very strong memory. The synapses have increased their strength significantly. Okay, let's compare then the strengths of the memory traces in the cortex and the hippocampus. In the hippocampus, according to our icon down here, we have a lot of ink that has been applied, and that represents the fact that hippocampal neurons were successful in greatly increasing the strengths of connections between the neurons that were activated by the learning event. So we have a strong memory trace. A lot of ink has been applied here. In the cortex, by contrast, it's a very different story. In all of those cortical areas that responded to the event, we have weak memory traces. Again, just to remind ourselves that in these cortical areas, we have a population of neurons, and a set of those neurons respond to the unique characteristics of the event, and then only a subset of them will be involved in forming a memory trace by strengthening neural connections. But the idea here is after one learning episode, we're left with weak cortical memory traces, but thankfully we have a strong memory trace down there in the hippocampus. Now, why is that the case? Well, one way to think about this is that not all neurons are created equal. The hippocampal neurons enjoy high plasticity, so they can make large increases in synapse strength after one learning episode. And we'll kind of show it over here with our icon. You see before learning, there's some baseline level of communication between these two neurons. After learning, we're showing the strength of the synapse has increased by just having a larger terminal there. That's our icon for a strengthening of synaptic connection there. By contrast, up in the cortex, the idea is cortical neurons show lower plasticity. They make smaller increases in synapse strength after one learning episode. If we keep track of these neurons then, again, the hippocampus shows fast growth, one learning episode. And now, to connect with one of our metaphors, it's as if the hippocampus is a fast learner. It responds very well to a single learning event. It responds well because it can make strong gains in synapse strength with just one learning event. By contrast, the cortical neurons, it's as though it takes longer for them to strengthen their synaptic connections. In fact, it takes repeated episodes of learning, right? So we're going to have to, if we want to build strong cortical memory traces, we've got to allow for the fact that cortical neurons show lower plasticity. So we've got to hit them repeatedly to help them strengthen those connections. And this has obvious implications for school. Repetition is needed. We must repeatedly study the same information, spaced out in time, so we give our brain a chance to strengthen those cortical synapses. Okay, in the next lesson, we'll take a look at what happens in the brain when we retrieve information.